Okay, so let's see binary in action. Right, here's a computer and it wants to print something on this printer here. It wants to print the letter A. Okay. Well, as you well know from previous gobbets, computers only deal in ones and zeros, binary numbers. So somehow we need to convert this A into a binary number. We need to encode it. Encode to binary. This has been worked out many years ago. They simply said, right, capital A is equal to the number 65, that's base 10. The letter B is 66, C is 67, and so on. This particular form of encoding, because there are many, this particular one is the most popular and used on most computers around the world that you will deal with. This is called ASCII. Funny name, but it's an acronym. American Standard Code for Information Interchange. And so now we've encoded our letter A into denary. Let's now convert that into binary. And as you well know, you first of all need a byte, 8 bits. 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. Okay, 65 is 1 in the 64, 1 in the 1, and zeros throughout. So 65 base 10 is 0, 1, 0, 0, 0, 0, 0, 1, base 2. Like so. Okay then, so how do we communicate that from a computer to a printer? Well, first of all we have to convert it into electrical signals, and again we need to have some kind of protocol here. So let's go with 1 is equal to plus 5 volts and 0 is equal to 0 volts. Okay, brilliant. So what we have here really is 0 volts, 5 volts, 0, 0, 0, 0, 0 and 5 volts. And we need to transmit that from the computer to the printer over a cable. There we go. We're going to transmit this one bit after another. That is called in series. We are going to we're going to transmit each bit one after the other, which is called series. There's another way of transmitting called parallel, which I shall maybe refer to in a minute. Okay then, so we've got one cable, and we're going to transmit the first bit plus 5 volts. This one here. The next one is going to be 0 volts, 0 volts, 0 volts, 0 volts, 0 volts, 5 volts, 0 volts. So it would be like this. Over a period of time. 1, 2, 3, 4, 5, 6, 7, 8 periods of time. That's because we're transmitting in series. Now, in the olden days, like when computers were, starting to become popular, back in the, I guess in the late 80s, transmission speeds were very, very slow. You had this thing called a baud rate, B-A-U-D, baud rate, which basically meant bits per second. And in the olden days, transmission over modems was generally 56 kilobits per second, or 56k baud. So you could transmit 56,000 bits, binary digits, per second. which may sound a lot, but if you've got a large document with many characters in, that'll take a lot, many of these little time slices to send it through. Okay, so to recap then, you want to print the letter A, that means transmitting it to the printer. You must first encode it to binary, encoding it using an encoding table, and in this particular case we're going to use ASCII, which is the most popular. So the letter A is equivalent to the number 65, base 10. So then we convert it to binary, and we get this number down here. Then we need to convert the binary into some kind of electrical signals. So let's say 1 is equal to plus 5 volts and 0 is 0 volts. And then we transmit it over a period of time, these little time slices, which has been agreed before between the two devices using baud rate. And that's how you transmit the values in series, I should say. In parallel, which was what came next, you had 2, 3, 4, 5, 6, 7, 8. You had 8 cables all at once, and this was called a parallel. I'm going to spell this wrong. Parallel cable. I do apologise. Because rather than sending it in series, you could send the whole byte in one time slot. So, say this would be plus 5 volts, and this would be 0, 0, 0, 0, 0, 5, and 0. And so rather than taking 8 time slots to send a byte, it only took 1 time slot to transmit from the computer to the printer. So you can see it sped up things quite considerably. And the only disadvantage really was that you had to have a special ribbon cable. Sorry, it was parallel or ribbon cable. Right, that's that.